This section is about supply and demand. In supply and demand equations, P will typically stand for price, and price is given in dollars usually. Q will stand for a quantity of units. S stands for the supply equation, and D stands for the demand equation. Naturally, we'll find that when supply increases, demand tends to decrease. This first example will illustrate that concept. It says market research performed by the Baby Buggy Company suggests that the demand equation for its buggies is given by Q equals negative 0.4 P plus 190, where Q is the number of buggies it can sell in a month if the price per buggy is P. So where could they come up with an equation like that? Well, they could have taken empirical data from the past and compiled it into a linear regression. And perhaps this is the mathematical model that came out of that. So let's sketch a graph of Q versus P. What would be the demand if the company were to just give away the buggies? Alright, so let's put Q up here, and remember that is quantity, and then we'll put P, price, over here. In some problems we'll have Q on the vertical axis, and some problems we'll have P on the vertical axis. Just depends on the problem. Now let's sketch a graph of what this function would look like. Well, it starts up high at 190, that's the intercept. It's got a slope of negative 0.4, so it's sloped downward. So it's sloped downward. Now it says, what would the demand be if the company were to just give away the buggies? Let's find the answer according to the mathematical model. In that case, we would plug in a 0 for the price. So let's plug in a 0 there. Let P equal 0. And we get Q is 190. So consumers would demand 190 buggies. According to the model, what would be the demand if the price was set to $50 per buggy? In that case, we just want to put a 50 in for P. So let P equal 50. And now they'll demand 170 buggies. So that point would be somewhere around here. 50, 170. Now what if they raise the price further? How many buggies will consumers demand then? Say they raise the price to $100. Now the quantity demanded is 150. And the last question asks, according to the mathematical model for demand, at what price would demand be 0? They're asking for this price right here. Alright, so let's set the demand equal to 0. Now we'll want to solve for P. $475. If they charge $475 per buggy, it's too much. Nobody would want to buy one. Now, of course, this is a mathematical model of a situation, and it's not expected to perfectly match reality. In all reality, perhaps the data might be something more like this. Okay, but if we use linear regression, then we're just going to get a straight line. So it may be that even if they were to charge $1,000 for a buggy, maybe somebody would still buy one. Or perhaps if they were to give the buggies away, maybe a lot of people would take buggies, maybe even more than 190 buggies. But the linear regression predicts these values here, and that's fine.